Alright, so we're going to take a look at something similar to dilation. We're going to look at a concept which is known as partitioning a segment. Partitioning a segment means breaking a segment apart into a given ratio. So what we're going to take a look at is taking a segment and a directed line segment, one that represents moving from point A to point B. So let's take a look at this example. So let's take directed line segment that joins points from coordinates 0, 0 to 8, 8, and we want to divide that in a 3-to-1 ratio. So if we're going to do that, think, how many different parts do we need to put that into? Well, 3-to-1 is a ratio of 4 different parts. So if I want to break this into 4 equal parts, notice I want to break its vertical component and its horizontal component into 4 parts, because a line has a slope, which is a rise over run. The rise is the vertical change, the run is the horizontal change. So we want to find the specific location that puts this directed line segment in a 3-to-1 ratio. So if I take a look at what I have right now, notice that the slope of this line segment is 8 over 8, which is 1. So the slope is 8 vertical, 8 horizontal, which is a change of 1. Which means if we want to break it into 3-to-1 ratio, we need to break that into 4 equal parts. And looking at this one, it's easy to see that we have a vertical rise of 8, which if I were to break that into 4 equal parts, we could divide that by 4 to get 2. So the vertical change, 2, 4, 6, and 8. Same with the horizontal change, every 2, 4, 6, and 8. Now if I want to break that down and find out a 3-to-1 ratio, so I count up 3, and find on this line segment that coordinate. And I find my coordinate is at 6, 6. Because that is the point where it divides it in a 3-to-1 ratio. It divides it vertically, 3-to-1. We have 3 parts below, 1 part above. Horizontally, we have 3 equal parts to the left and 1 equal part to the right. Okay, so that's the basic form. When it comes out evenly, we can kind of just look on the graph and divide it. And we take a look at our slope, 8 over 8. We can divide those into 4 equal parts. And we get 2 over 2, which means we need to divide it into equal parts based on 2's. And then if we want a 3-to-1 ratio, we can multiply those parts by 3 to get a vertical rise of 6, horizontal change of 6 from our original segment. So up 6 over 6 gets us to that point. Okay, so let's take a look at another one where we have AB. A is 3/4, B is 6/10. We want to change this into a ratio of 3-to-2, which means you want 5 equal parts. Okay, so now taking a look at this segment, as we take a look at its rise over run, we go up 6 units, we go over 3 units. So our slope is up 6 over 3. That's the total change on this directed line segment. Now, we mentioned we want to divide this into 5 equal parts. So if we divide the vertical change into 5 and the horizontal change into 5, notice we get 6/5 or 1.2, and 3/5 would be 6/10, or 0.6. Now we want this 3-to-2 ratio. So from A to P, which is the new point we want on there, we need 3 of those parts. So let's multiply those parts by 3, because we know we're going to group this into equal parts. So 1.2, another 1.2, another 1.2, another 1.2, another 1.2. And these are 0.6 up here. 2.8. Okay, so we've got 1, 2, 3, 4, 5 equal parts, 1, 2, 3, 4, 5 equal parts. Okay, so if I were to eyeball it, I'm going to go up about 3. So it's going to be about here. That's where these parts meet. I have 3 parts up, 2 parts left, 3 parts, and 2 parts. Now let's find the exact coordinate, because by eyeballing it, it might not be exact. So 1.2 times 3 gives us 3.6, which is our vertical distance. This is our horizontal with rise over run, and 0.6 times 3 is 1.8. So my rise of 3.6 from my original point A, and a run of 1.8. So from A, I'm going to go up 3.6 and over 1.8. And so if I add those to my coordinate, A was originally 3, and I'm going right 1.8. And from the original y coordinate of 4, I'm going up 3.6. So that means my new coordinate will be 4.8, 7.6. And I can plot that point on my graph. Go up 1, 2, 3.6, and over 1.8, I'm at 4.8, 7.6. And that'll be coordinate point P. It says we want to find point P that divides it. So AP is in a ratio to PB in 3 to 2. So actually, this should be point P. We were just adding it on from point A. Notice I could have taken point B and gone backwards, but then I would have only wanted 2 parts. So I would have had to recalculate instead of times 3 times 2. And then I would have needed to go backwards, left 2 parts and down 2 parts. Okay. Now let's take a look at how we can construct a point using our compass. So if we want to construct a point L on AB, so first of all I need to create line segment AB. I'll just label this point A and point B. And I want to divide this into 4 equal parts, a ratio of 3 to 1. I need to find point L on there that is exactly 3 parts over. So how I'm going to do this is I'm going to draw another line. And what I'm going to do is divide this line now into 4 equal parts using my compass. And as I take my compass out, I'm going to divide this one up. I'll just open the compass up any length and set it on point A. And what I will do is open the compass there. It's 1 part, 2 parts, 3, and now 4 parts. Okay, because we need 4 equal parts. Now we need to transfer those parts over to our other line. So let's label these points C, D, E, and F. And now I'm going to get my straight edge. I'm going to connect B to F, because I know those need to match up there. Now, if I can take this angle of AFB and copy that angle down so that I get parallel lines, notice I would have a couple of dilated triangles, and I would know that all these lines would be in proportion. So I just now need to dilate the figure, or not dilate the figure, copy the angle. So I'm just going to take my compass now. I'll shrink it down a little bit. And I'm going to copy this angle here. So I'll do the same for every point at E, D, and at C. Next, I need to copy that distance. So if I open my compass up, there we go. But I need to set my point on this intersection here. I want to copy how large the angle is open. So let me open my compass. I'm going to mark that angle. And I'll go to this intersection here, mark that. Same here. And same at this point. Now once I have all those intersections, I'll get my straight edge out again. I'm going to connect from point E through that intersection all the way down. Same with D through the intersection all the way down. And same with point C through my intersection all the way down. And then these parts, we call this G, we could call this H, and we want point L on here that's 3-to-1 ratio, so we'll call this L. I know it's out of alphabetical order, but that's okay. So L, we'll make this 3 parts because we have 4 equal parts now. 1, 2, 3, 4. And point L is 3 equal parts from A, and LB is 1 equal part. So notice we've got these 4 similar triangles, and it looks like a dilation. You know, as we're getting larger, this one just increases in size from one triangle to the next because we've copied this angle down. They share an angle, and you know, we made them all parallel, so all the side lengths are proportional now. All right, so we'll do some work now on practicing finding those specific coordinates on the directed line segment in that given ratio, and using our compass to find the exact point that divides the segment into that given ratio.